Welcome to our channel. In this video, we should discuss some of the fundamentals on determinants. So let's begin. Determinant means it is simply an arrangement of various elements in equal number of rows and columns. That means the arrangement of numbers, symbols, alphabets or various elements in equal number of rows and columns within two vertical bars is called determinant. So here we should arrange the various elements. Say it may be an alphabet, or it may be any number, or it may be any symbols, or any other elements should be arranged in a proper order. That means we should arrange the elements in equal number of rows and columns within two vertical bars. One is in the left and the another one is in its right. So such arrangement should be made either in 2 into 2 order, or it may be made into 3 into 3 order, or it may be arranged in 4 into 4 order, and so on. But generally determinants are broadly divided into two types, that is second order determinant and third order determinant. Here the second order determinant means the determinant having two rows and two columns is called our second order determinant. Whereas in case of our third order determinant, there is 3 rows and 3 columns. That means the determinant having 3 rows and 3 columns is called our third order determinant. So let's take an example of our second order determinant, that is equals to A is the determinant having 4 elements, that is 2 rows and 2 columns. Whereas our third order determinant consists of 9 elements which contains 3 rows and 3 columns, that is 3 into 3 order. So in case of second order determinant there is 4 element, and in case of third order determinant there is 9 elements, and in case of third order determinant there is 3 rows and 3 columns, whereas in case of second order determinant there is 2 rows and 2 columns. Generally the elements present in horizontal lines are called rows of the determinant, whereas the elements that is present in a vertical line, that is called column of the determinants. Generally the determinants are named by capital letter, whereas the elements of the determinants are small letters. So in order to find out the value of the determinant, we should follow different procedures. In case of second order determinant, the value of the determinant is obtained by multiplying the elements of principal diagonal and deducting therefrom the product of the elements of cross diagonal. That means in our given example, the determinant value of A is the product of principal diagonal, that is AD, and deducting therefrom the product of cross diagonal elements, that is CB. So the value of the determinant is AD minus CB. Whereas the value of the third order determinant is obtained by multiplying each element of any row or column by the determinant value of sub-determinants obtained by omitting the concerned rows and columns by considering the respective signs of the given elements. So in case of third order determinant, generally the value of the determinant is, in case of our given example, the value of determinant is A into the value of the sub determinant, that is QR NP minus B into the value of the sub determinant, that is PR MP plus C into the sub determinant value, that is PQ MN. So by simplifying, that is A whole into QP minus NR minus B whole into P square minus MR plus C whole into PN minus MQ. Generally, we use 4 methods for finding the value of the determinant, that is minor method, expansion method, cofactor method, and Saras diagram method. So before using any method for finding the value of the determinant, we must come across certain specimen, that is specimen of sign, specimen of the minor, specimen of cofactor, and specimen of elements for computing our value of the determinants. So let's discuss one by one. So the specimen of sign is plus minus plus minus plus minus plus minus plus, whereas the specimen of our minor is M11, M12, M13, M21, M22, M23, M31, M32, M33, and the specimen of our cofactor is C11, C12, C13, C21, C22, C23, C31, C32, C33, and the specimen of the elements of a determinant is A11, A12, A13, A21, A22, A23, A31, A32, A33. So these are the some important specimen that should be remembered in order to find out the value of the determinants. So specimen of sign is plus minus plus, minus plus minus, plus minus plus, and the specimen of the minor is M11, M12, M13, M21, M22, M23, M31, M32, M33, and the specimen of the cofactor is C11, C12, C13, C21, C22, C23, C31, C32, C33, and the elements of the determinant is A11, A12, A13, A21, A22, A23, A31, A32, A33. Generally, the subscripts given against the minor or cofactor or the element represents the position of the elements in the given determinant. Here M11 means the minor of first row and first column. Similarly, here M32 indicates the minor of third row and second column. Similarly, here C22 indicates that the cofactor of second row and second column. So the subscripts are used in order to identify the position of the given minor, cofactor or the elements in our concerned determinants. So these are the various specimens that we should remember in the determinants. So now we should consider different methods of finding the value of the determinants. So now come to our various methods of computing determinant value. Generally, there are 4 methods used to find out value of the determinant, that is minor method, second one is cofactor method, third one is our expansion method, and fourth one is Saras diagram method. Now we should discuss different methods one by one. So now first come to our minor method, the method in which determinant value can be find out by using the minors of the elements of any row or column is called minor method. Generally, determinant value is obtained by using the formula that is A11 into M11 minus A12 into M12 plus A13 into M13. Similarly, we also can find out the value of the determinant under minor method by using the second row, third row or any other columns. In that case, we should multiply the elements of any row or column with their respective minor values, and then we should carry on the operation of algebraic operation by using their respective signs in order to find out determinant value. So now come to our cofactor method, the method in which determinant value can be found out by using cofactors of the elements of any row or column is called our cofactor method. Generally, we can find out value of the determinant by using the cofactors by following the rules, that is A11 into C11 plus A12 into C12 plus A13 into C13. That means the value of the determinant under cofactor method is the sum total of product of each element of any row or column with their respective cofactor values. So now come to our third method, that is expansion method. Under this method, we can find out the value of the determinant by expanding any rows or columns. So for finding the value of the determinant or expansion method, we must come across the specimen of the elements of our determinant, that is A11, A12, A13, A21, A22, A23, A31, A32, A33. So under expansion method, the value of the determinant can be obtained by expanding any row or column, and also we should consider the respective signs. So by expanding first row, we can find out the value of the determinant, that is A11 into A22 into A33 minus A32 into A23 minus A12 whole into A21 into A33 minus A31 into A23, then plus A13 whole into A21 into A32 minus A31 into A22. Similarly, we also can expand any other rows or columns in order to find out the value of the determinant under expansion method, but we must be carefully consider the respective signs of each element before expanding. So now come to our fourth method, that is Saras diagram method. The method in which we should use the diagram suggested by Saras in order to find out the value of the determinant is called Saras diagram method. Under this method, we should follow certain steps before computing the value of the determinant. So such steps are, in our first step, we should repeat the elements of first column and the elements of second column as our fourth column and fifth column respectively. Then in our second step, we should find out product total of the elements of our principal or main diagonal. Then in our third step, we should find out the product total of the elements of our cross diagonal elements. And in our fourth step, we should find out the difference between product total of main diagonal element and the product total of cross diagonal element. So the rule under Saras diagram method is the difference between product total of main diagonal element, that is the value of the determinant is product total of main diagonal element minus product total of cross diagonal element is our determinant value under Saras diagram method. So these are all about the different methods of computing our determinant value and their rules. So now come to various features of our determinant. So the different features are: the first feature is it has equal number of rows and columns. Then our next feature is it has a definite value or particular numerical value. Then the next feature is it has two vertical bars, that is first one is in its left side and another one is on its right. Then our fourth feature is it is named by capital letters of English alphabet, whereas its elements are always small letters. Then the next feature is each and every determinant is a square matrix. The next feature is each element contributes to the determinant value. Then our next feature is the number of elements elements of a determinant is the product of rows and columns of the given determinant. So let's repeat again. The various features of our determinant are it has equal number of rows and columns. That means in case of each and every determinant, the number of rows must be equal with the number of columns. Then our second feature is it has a definite particular numerical value. Generally, we can find out a particular value of the determinant, or each and every determinant has a definite or particular values. Then our next feature is the elements of a determinant are always arranged within two vertical bars. One is on its left and another one is on its right. Then the next feature is each and every determinant is always named by the capital letters of English alphabet and its elements are always small letters. Then our next feature is it is a square matrix, or each and every determinant is considered as a square matrix. Then the next feature is each element contributes to the determinant value. That means in order to find out the determinant value of a determinant, we must consider each and every elements of the given determinant. Then the next feature is the number of elements of a determinant is the product of the rows and columns of the given determinant. So these are all about various features of our determinant. So repeatedly watch this video in order to clear all your doubts and share it with your friends. Thank you.